Hello, this is Ms. DB, and today we are going to continue our work in Chapter 2 with Chapter 4 with Section 2 on angle relationships in triangles. We're going to learn a lot of theorems today. Either have your notebook note-taking guide out so that you can follow along and star these theorems as you find them, or else write the theorems down in your own notebook as you go. You'll want to be able to remember these. Our objectives today are to find the measures of interior and exterior angles of triangles, and we will do that with several different theorems, and then use those to find missing angle measures mostly. Here's our vocabulary for today: auxiliary line, corollary, interior, exterior, that's of a triangle, interior angle, and exterior angle, again of a triangle, and then the remote interior angle. All right, we're going to start off with a theorem. Here's the first one you should either write down or find on your note-taking guide. The triangle sum theorem says that the sum of the angle measures of a triangle is 180 degrees. That means the measure of angle A plus measure of angle B plus the measure of angle C equals 180. There is a proof of this in your it's a video proof showing how to prove this in the week 9 folder, and it's also right here, and it's important enough that I think we're going to watch it right now. It does use an auxiliary line, which is just a line that you add to a figure to aid in a proof. All right, so here is the video proof of this.
We know that the sum of angles within a triangle is 180 degrees. Let's prove that for triangle ABC. To prove that, we need to do a small bit of construction. We draw a line EF passing through point A and parallel to BC. It will look like this. It passes through point A and is parallel to BC. You can see that many angles are formed. Let's name them. Let this be angle 1, let this be angle 2, and let this be angle 3. Angles 1, 2, and 3 are the interior angles of the triangle, and their sum equals 180 degrees.
She really shouldn't say that yet because that's what we're going to try to prove. Also, angle 1, 2, and 3 do not need to be congruent to each other. They are not necessarily, this is not necessarily an equal angular triangle. They kind of look like it in this one, but you could draw any kind of triangle to do this proof.
There are two more angles that are formed outside the triangle. Let's call them angle 4 and angle 5. Before we move forward, let us understand a new concept. Assume these are two parallel lines and there is a transversal that cuts those lines. Let this be angle 4 and this be angle 2. In such a case, angle 2 will always equal angle 4. These are alternate interior angles. Remember, the transversal has to cut two parallel lines. Now let's zoom out and look at the original figure. BC and EF are parallel lines, and angle 2 and angle 4 are alternate interior angles, which is why angle 2 will equal angle 4. If you look at the figure carefully, you will notice that angle 3 and angle 5 are alternate interior angles too. AC is the transversal which intersects these two parallel lines. It means that angle 3 will also be equal to angle 5. Both these pairs are alternate interior angles. What we're interested in is the sum of these three angles. Angle 1 plus angle 2 plus angle 3. Since angle 2 is equal to angle 4 and angle 3 is equal to angle 5, we can write this as angle 1 plus angle 4 plus angle 5.
She used substitution there to say that instead of angle 2 she put angle 4, and instead of angle 3 she wrote angle 5. So substitution was used.
We just replaced angles 2 and 3 with angles 4 and 5. What does this tell you? Look at the figure and see where angles 1, 4 and 5 are placed. EF is a straight line, and since EF is a straight line, We know that the sum of angle 1, angle 4 and angle 5 will equal 180 degrees. It implies that the sum of angles 1, 2 and 3 will also equal 180 degrees.
So that's the proof of why the sum of all the interior angles of a triangle are equal to 180 degrees. All right, so continuing on in our lesson, now we will use that's showing how to use the proof. All right, so now that we know that, we can find missing angles in a triangle. So here we are going to, it's an application problem just because they are giving you a situation that would cause you to want to draw this triangle. So they say that there's a car accident and the cars are at, the vertices of the different triangles. So the cars are at W, X, Y, and Z, and the angles are given. So we want to see if we can figure out the measure of angle X, Y, Z. So find X, Y, Z. You should be really good at finding which angle they're talking about. In this case, they're talking about this angle up here. Well, so that means that we're looking at triangle X, Y, Z. We're not worried about this little W part here right now. And in triangle X, Y, Z, we know two of the angles, one's 62 and one's 40. So if the missing one, if we added that together, that would have to equal 180. So you plug in the 40 and the 62, and you're missing one thing, and that's measure of angle XYZ, which is what we're trying to find. And we subtract, and we find that it's 78 degrees. Now, you don't have to write all of these steps to do that. These are kind of very specific, and they've got their reasons and everything. If I was doing this problem, I would say, well, let's see, 180 minus 62 plus 40. That's probably how I'd do it. That's my missing angle. Now, I can't call that angle Y, really, because angle Y might refer to the one that I want, or it might refer to this little tiny one, or it might refer to the whole thing. But I can just say, I don't know, A is equal to that, and then I'll call this angle A. Or you could call it angle 1, or whatever you want, just to make it a little simpler to write. So 180 minus 62 plus 40 is 102, and then you get the same answer they got. I'm saying you don't have to write every single little tiny step down for these. Whoops. Okay, here's another one. In this one, they're finding same picture, same car accident, but this time they want us to find a different angle. Angle W, YWZ. YW, it's this angle. YWZ. Okay, I know one of the other angles in the triangle, this little one here, is 12. I don't know this one. How do I find that one? That's angle WXY. You find that angle because together with 62, it forms a linear pair. These two together form a straight line, which is a linear pair, which add up to 180 degrees. So basically, take 180 minus 62, and you'll find the missing angle of that triangle. So this angle right here is 118 degrees. Now there's a whole other page showing how to find the measure of angle W then, or YWZ. And basically we're going to say, well, that angle, W, plus 12 plus 118 will equal 180. Or you could just take 180 minus and then add the other two together. So this is a short way of writing what they're going to have on the next page here, which is pretty much the same thing. You use the triangle sum theorem, you plug in, use substitution, and then you simplify, subtract, and you end up with 50 degrees. So angle YWX is 50 degrees. A corollary is a theorem whose proof follows directly from another theorem. It's like a special case of the theorem. Here are two corollaries to the triangle sum theorem. Remember, the triangle sum theorem is that if you add up all the interior angles of a triangle, you get 180 degrees. Here's two corollaries. The first one, 422, says the acute angles of a right triangle are complementary. So if you know you have a right triangle, this angle plus this angle will equal 90 degrees. So in this picture, measure of angle D plus measure of angle E will equal 90. And the second corollary, 423, is that the measure of each angle of an equiangular triangle is 60 degrees. So if you know that it's equiangular, then you know that every angle in there is 60 degrees. The proof of this one is not bad at all. You would just say that you know that the measure of angle A plus measure of angle B, whoops, I hit a button, plus measure of angle C would equal 180, and then you just use algebra to say that if they're all equal to each other, I can substitute. I'll substitute measure of angle A for measure of angle B, and I'll substitute measure of angle A for measure of angle C as well. And then it's kind of like the distributive property in reverse, or using like terms, you would say 3 times the measure of angle A is equal to 180, therefore measure of angle A equals 60. But because they're all congruent to each other, then they're all equal to 60. That's really all there is to the proof of that one. So let's use that. We won't use the one about the equiangular hardly ever. Just memorize that if you have an equilateral or an equiangular triangle, every angle is 60 degrees. Memorize it. Do it now. You'll use it for the rest of your life probably. All right. Here's the other corollary, though, that if you are given a right triangle, the other two angles will be complementary, meaning that the sum of their degrees, the measure of their angles, will equal 90 degrees. All right, so in this one we have one of the acute angles in a right triangle measures 2x. What's the measure of the other acute angle? So what we're going to do is we're going to let one of the acute angles be 2x. We'll call this one 2x. And we know that that plus measure of angle B will equal 90. If we subtract 2x from both sides, we get that the measure of angle B is equal to 90 minus 2x. Now, some of you are going to be like, well, it's not even done. What's the answer? The answer is we don't know. I mean, that's as far as we can go. We can only get an expression for this. We can't get an absolute answer. Here's another example. This one we might be able to get a little bit more of an answer because instead of giving us x, they're giving us 63.7 for something. It says the measures of one of the acute angles in a right triangle is 63.7. What's the measure of the other acute angle? So we'll let 63.7 be measure of angle A, 63.7 degrees. And we know that together measure of angle A plus measure of angle B equals 90, using the corollary. And 63.7 plus measure of angle B equals 90. Subtract 63.7 from both sides. This time we can actually get a numerical answer. And sometimes that makes us happier, but other expressions are fine for answers too. Okay, one more example like this. It says the measure of one of the acute angles in a right triangle is x degrees. So here's our right triangle. Here's our x. What's the measure of the other one? Can we find an exact answer here? We substitute x in, we subtract, and all we get is measure of angle B equals 90 minus x. We can't solve any farther. That's as far as we go, and then that's it, we're done. And here's one that we might get a numeric answer for. We'll call, let's see, we'll call this A, B, and here's our 90-degree angle. So over here we have 48 and 2/5. It's a fraction. Some of you may prefer to change that to a decimal. So take 2 divided by 5 and you'll get 0.4, which means that this would be 48.4 degrees if you prefer. And then we would say that the sum of those is equal to 90 because it's a right triangle. And then we need to subtract 48 and 2/5 from both sides. And we get that the measure of angle B is 41 and 3/5, or if you had changed it to a decimal, you would get 41.6 degrees. So that one we actually get a numeric answer for. All right, so if we are talking about a figure, especially a triangle, the interior is the set of all the points inside the figure. Every point inside of here is in the interior. And the exterior is all of the points outside. Okay? So there's an interior and there's an exterior of all figures, including triangles. All right, so in this picture, they're showing some interior angles and some interior and exterior angles. Angles 1, 2, and 3 are interior. Angle 4 is exterior. So an interior angle is formed by two sides of the triangle. An exterior angle is formed by one side of the triangle and the extension of an adjacent side. So this image only shows one exterior angle. It shows that it's formed by this side of the triangle and an extension of another side. You would have another exterior angle by extending this side. Here's another exterior angle right here. See that? And another exterior angle you would have, there's lots of exterior angles. Here's another exterior angle. And we could draw the lines the other way and have different exterior angles. It just depends on which way you continue your line. So maybe I would have drawn it this way. Here's another exterior angle. Okay? There's some theorems about interior and exterior angles and how they relate to each other. Oh, also, remote interior just means an interior angle that is not adjacent to the exterior angle. So angle 4 is exterior. These two are both remote interior angles because they don't touch angle 4 at all. Angle 3 is right next to angle 4. That's adjacent. That's not remote. So here's our exterior angles theorem. It says that the measure of the exterior angle is equal to the sum of the non-adjacent or the remote interior angles. So if you know the measure of angle 1 and the measure of angle 2, you can add them together and it'll equal the measure of angle 4. So angle 1 plus angle 2 equals the measure of angle 4. Let's use that theorem to solve some problems. So we want to find the measure of angle B. It's up here. Well, let's see. I am given that the exterior angle is 5x minus 60, an expression, and that the remote interior angles, A and B, are given as 15 degrees and 2x plus 3. So the theorem, exterior angles theorem, says that the exterior angle measure will equal the sum of the two remote interior angles. So I'm going to write an equation that says that. It says the measure of angle A plus the measure of angle B equals the measure of angle BCD. And then we'll use substitution to put those expressions in, and we get 15 plus 2x plus 3 equals 5x minus 60. Combine your like terms, and you get 2x plus 18 equals 5x minus 60. Now we need to get our x's together on the same side, so we'll subtract 2x from both sides, and then we'll end up adding 60 to both sides after that, and we'll end up with 78 equals 3x, divide by 3, and 26 equals x. Now be careful because that's not what they ask us to find. They ask us to find the measure of angle B. So if x is 26, you can plug that in for x and take 2 times 26 and then add the 3, and you'll get that the measure of angle B is 55 degrees. So then you answered the question. Here's another example. Now in this one, notice that there's no angle measure given, but it's marked as a right angle. So when you start to solve this, we'll start the same way, that the exterior angle measure is equal to the sum of the two remote interior, and we'll use 90 degrees for angle B. Even though it's not marked 90, we know that every right angle is 90 degrees. And then we simplify, add their like terms, get our variables together on the same side, so subtract z, 2z I mean, and we get 4z minus 9 equals 91, add 9, and we get 4z equals 100, divide by 4, and you get z equals 25. And then your last step is just to say, okay, once you know what z is, we have to find the measure of angle ACD. ACD, that's this one. So we replace z here with 25, so we'll go 6 times 25 minus 9. And 6 times 25 minus 9 is equal to 141. Another theorem, so make sure you get this one down too, is that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. That makes total sense, right? If the sum of both of these has to be 180 degrees, and you already know that, let's say both of these are 40 and both of these are 30. So let's say these are 40 and these are 30. So I've used up 70 out of my 180. So I must have 110 degrees left. Which way did I go here? And the same thing would happen over here. I'd have 180 minus 70. So the third angles of both of them would be 110 degrees. So you don't even have to know the specific angle measures. You just have to know this theorem that says that if it's true that angle L is congruent to angle R and angle M is congruent to angle S, then you'll know that angle N is congruent to angle T. All right, let's use that theorem. Now note that there's two triangles overlapping here. We have FHK, that's one of our triangles, and our other triangle is JGI. So watch which ones are the same here and which ones are different. So in the blue triangle, we are given that angle F is marked with 2 angle marks, and so is angle I. So angle F is congruent to angle I. And we also have that angle H in our blue triangle will be congruent to angle G. And I know that because they're both marked with 1 angle mark, which means then that using the third angle theorem that angle K must be congruent to angle J. And if that's true, I can say that their two expressions are also going to be equal to each other. Okay, so we substitute in and we get 4y squared equals 6y squared minus 40. So now we're going to subtract 6y squared from both sides. Let me erase some of this. And when I do that, I'm still going to get y squared. I'm going to get negative 2y squared. Then we would divide both sides by negative 2. So I subtracted 6y squared, subtracted 6y squared. Now I'll divide by negative 2. And I'll get y squared equals 20. Now, the answer is not 10. It says y squared equals 20. You need to take the square root of both sides to find y. However, they did not do that because the expressions themselves, I'm going to write it here anyway just in case somebody would like to solve for y. But they didn't even bother because the measure of angle K was 4y squared, but y squared is 20. So if I could have wrote 4 times the square root of 20 and then squared the square root of 20, but that would just give me 20 back again. So it's easier to just leave it as y squared. And then you get 80 degrees. And we already knew that the other one was congruent to that, so I don't need to plug in here. I can just say, well, they're equal to each other, so they're both 80. I don't have to do the extra work of going 6 times 20 minus 40. All right? So that was an instance where you didn't have to go all the way to solving for y. We could stop at y squared in that one. All right, just a couple more examples here just to help you out on your homework. Measure of angle P and measure of angle T is what they're looking for. Those are the third angles, and we know that angle P is congruent to angle T because of the third angles theorem, because angle N is congruent to angle S, and angle M is congruent to angle R. That's given from the picture. So then we could use the third angles theorem to say that these two angles are congruent to each other, and then we substitute in their expressions. And again, I don't know why, but they decided to use squareds in this one, just to remind you about something being squared, I guess. Divide by negative 2, and you'll get x squared equals 16. Now, in this case, you might say, well, x is 4, and just be done with it. But you wouldn't have to, because the expression for a measure of angle P is 2 times x squared. So whatever x squared is, in this case 16, and times it by 2, gives us our answer of 32. Or you could have found that x is 4, and then squared it and got 16, and then multiplied by 2 to get 32. Now, measure of angle T is going to be the same thing because they're congruent, so it's also 32. Okay, here's our last problem for today's lesson. We're going to find the measures of angle S and U. This one doesn't have squares in it. So can we use the third angles theorem? Let's see. We have that angle T, oh, I can't call it angle T because it's in between too many things. So let's do it over here. Angle UTR, that's this angle, is congruent to angle SRT. Okay? We also know that angle URT, that's this one up here, is congruent to angle STR. STR, that's this one down here. Therefore, I can say that angle U is congruent to angle S. These were both givens by the picture. And this is the third angles theorem. You don't have to state your reasons in solving these problems, but just so you know. Then I will replace the measures of the angles with what they are, their expressions. So 5x minus 11 will be equal to 4x plus 9. And now I just need to find x. X minus 11 equals 9, add 11. So x equals 20. Now we're not done until we find the measure of angle S and U. Well, how are we going to do that? Oh yeah, we have an expression. So angle U is 5x minus 11, so that's 5 times 20. 5 times 20 is 100. Let's see, 100 minus 10 would be 90, but we actually have one more than that, so 89 degrees. We should get the same answer over here. You could plug it in if you want, or you could just say it's 89. Let me just, it's not hard though. So this would be 4 times 20, which is 80. 80 plus 9 indeed is 89 degrees. So we know for sure we did it right then. All right, let me know if you have any questions as you're going over your worksheet for this. I hope you learned a lot. Don't forget to write down all these theorems from this section, or to print the page off with the theorems on it. It's at the end of your Chapter 4 note-taking guide so that you can refer back to these as often as needed. Thank you very much.